Welcome to Flexiant Concerto, the simple solution to multi-cloud workload management and portability. Unpredictable levels of web traffic can easily make it hard for your infrastructure to cope with demand. Traditional auto-scaling systems address this problem by reacting to infrastructure metrics and do not reliably represent what the end user perceives at any given time. This video will show you how Flexiant Concerto reacts to changes in the actual end user experience, measured directly within the application, and will spin servers up or down accordingly. After logging into Flexiant Concerto, you'll see the control panel displaying the infrastructure within the MyStore workspace. This is made up of the MyStore database and two front-end servers that make up the Magento website that you can see here. You can watch how we deployed this in another of our Flexiant Concerto videos, so be sure to check that one out. In addition, we have configured the new Relic tool. New Relic is the partner we have integrated with to enable application monitoring. Currently, all we have done is generated a new license key for a PHP application. Back to Flexiant Concerto in the blueprint area, we have configured the specific Magento front-end attributes with the same license key. To configure auto-scaling, we move back to the infrastructure area and the MyStore front-end server array. Let's enable auto-scaling. We choose a range of servers from 2, which is our initial infrastructure baseline, up to 20. This means that if web traffic demand increases, we can scale to up to 20 servers, but will never scale down to less than 2. We're going to use the AppDex metric, which is measured by New Relic for the Magento web application, corresponding to the license key we configured earlier. We now need to set our rules. The AppDex value ranges from 0 to 1, where 1 indicates optimal application performance. We're going to set our scale-up value to 0.7 and scale-down value to 0.9. This means that once the application performance decreases to a point where it hits the 0.7 threshold, Flexiant Concerto will automatically spin up additional servers. On the other hand, once performance has improved to the point where AppDex reaches 0.9, Flexiant Concerto will remove servers to keep costs at a minimum. Now we update the server array and head back to the server listing, which shows our infrastructure baseline. To simulate how auto-scaling would work in a real-life situation, we will utilize the Apache Benchmark tool to generate traffic. This tool can emulate thousands of requests from different clients, and it will help us to show how a new server is spun up when required. After launching the traffic emulator, you can now see that Flexiant Concerto has automatically started to build another server within this array to address the additional workload. Since it was created from the same template as the other two, it will connect to the same database and will be automatically added to the same network load balancing pool. Now we are going to stop emulating traffic and observe Flexiant Concerto killing the extra server that is no longer required. This is to keep the infrastructure footprint aligned to actual workload demand, helping to minimize your costs. Ensuring that you always have the right number of servers to meet web traffic demand can be easily and fully automated with Flexiant Concerto's intuitive interface. Thank you for watching. Now, take a look at our other videos and discover how you can transform the way you deliver other common and complex tasks with Flexiant Concerto.